Welcome. Today's topic is bus versus bridge in the motherboard. Many students feel confused about these terms. Don't worry, by the end of this video, all your doubts will be crystal clear. Trust me, after today's session, you will never look at the words bus and bridges in the same way again. Now think about this. How does your CPU talk to RAM or USB devices? Do they have separate wires? Or is there a shared pathway? Keep this question in mind and let's find the answer together. A bus is not a vehicle here, it is a communication pathway that transfer data, addresses, and control signals. Think of it as a highway in the cities residing inside your computer. By the word bus, because just like a school bus carries a student, a computer bus carries information between components. Easy to remember, right? Now, a doubt you may have: do CPU and RAM need separate wires? No, instead, they all share one common pathway, the bus. This makes design simpler and efficient. Does one bus do everything? No, we actually have three buses: data bus, address bus, and control bus. Let us clear them one by one. The data bus carries the real information. For example, when you open a file, its data moves through the data bus. But where should the data go? The address bus answers this. It carries memory addresses like roll number in class. And who gives the commands? That's the control bus. It sends signals like read, write, or stop. So the bus connects CPU, RAM, and devices like hard drives and USB ports. Without it, no component could talk to another. Data transfer happens in a step. First, the address, then the data, then the control signal. Everything happens in proper order. Why not separate wires for each device? Because that would be messy. By centralizing communication through a bus, computers becomes faster and more efficient. If this explanation has cleared your doubts so far, then please give this a video a like, share it with your friends, and don't forget to subscribe for more tutorials. Now let's move to the bridges. A bridge here doesn't mean the one you drive over. On the motherboard, a bridge is a chipset that manages traffic between CPU, RAM, and devices. I call bridge because just like a road bridge connects two places, this chip connects and control communication between fast and slow components. The North bridge handled high-speed tasks. It connects CPU with RAM and GPU. GPU here, graphics processing unit, essential for games and heavy applications. But in modern systems, the North bridge has disappeared. Its role is now integrated directly into the CPU. Southbridge, on the other hand, managed slower devices like USB ports, audio, and storage. Today, Southbridge no longer exists separately. It has it has been replaced by the Platform Controller Hub or PCH. What is PCH? What it do? And what is Hub? Note this, we are coming to this later on. Traditionally, Northbridge sat near the CPU socket. while Southbridge was below near the PCI slots. So earlier we had a two bridge design, Northbridge for fast device, Southbridge for slower ones. Later, to simplify things, both bridges merged into one chip, the platform controller hub. Now let us understand what is PCH. Look here, the CPU directly talk to high-speed parts like RAM, graphic, but all the slower devices, USB, storage through SATA, Ethernet, and audio, go through the central chip called PCH or Platform Controller Hub. That's why it is called hub, because it is the central connecting point for everything that doesn't go directly to the CPU. And now, modern CPU even include memory controllers inside them. This means bridges play a smaller role today. Let's clear all doubts in one go. Bus is pathway, bridge is controller chip, bus transfers signals, bridge manages communications. Bus still exists. Bridge are mostly integrated into CPU or PCH. Look here. On the left, buses are highway carrying data. On the right, the bridge is the traffic police controlling flow. Bus is like a school bus. Students are data, roll numbers are addresses, teachers command are control. Bridge are traffic police, they control and direct the flow. Now, let us test your understanding. Which bus carries memory addresses? Which bridge connects CPU and RAM? What replaced the South Bridge? Where is the memory controller today? Pause the video, think, and write your answer in the comments below. So, what did we learn? The bus carries, the bridge controls. That's the simple difference that makes everything clear. If this video cleared your doubts, then please like, share, and subscribe. It really motivates us to bring you more tutorials. Thanks for watching. See you in the next video.